Hello, Science Nines. I wanted to talk a little bit about the notes I sent out on resistance, at least the first part. And so if you're looking at this sheet here, I've added a couple of things. At the very top, there's what I call is a resistance spectrum. So if you start at the left, and as you go from left to right, you are becoming less and less resistant, I should say. So insulators have high resistance, and as you go all the way up, sorry about my writing here, as you go up to all the way to superconductors, you have low to no resistance. So um, there's just the spectrum in between. Semiconductors are right between insulators and conductors, just like it shows in the spectrum. And semiconductors, there's a quick property you should know about them. If semiconductors are cold, they actually act like an insulator. And if they get warmed up to the right temperature, then they'll start acting like a conductor. They're actually made out of something called metalloids, which, if you know your periodic table, that's metalloids are kind of the staircase that separates metals and nonmetals. Anyway, you guys will learn that in the chemistry part. Conductors are just standard metals, and then superconductors are awesome. They work best under cold temperatures, but they have almost no resistance. So anyway, all the other terminology is there. I should mention this as well. The resistance is another property of that we use to measure electricity, and it's measured in ohms, OHMS, or the symbol for it is the Greek letter omega. I just circled it right there. It's kind of like a horseshoe with feet, as I call it. So you have to recognize that symbol and answer when you're calculating resistance. You need to express your units in ohms. Two other quick things about resistance. Thick wires have low resistance, and thin wires have high resistance. Thick wires, there's more area for electrons to kind of maneuver through the metal. So with thicker or larger diameter wires, those have low resistance. But really thin wires, like the thin wires in your toaster or the thin wires in a light bulb, are really, really high resistance, and so they generate a lot of heat for good purposes. And then the other one is that longer lengths of wire have more resistance than shorter lengths. So if you have a really long length of wire, the electrons and current have to pass through a greater distance. What I wanted to show you now is a bit of the practice assignment. So on calculating resistance, a lot of you guys already started this. I want to walk through this quick method right here. It's called the GRASP method. And what it involves is identifying what you're given from the question, what's required are, analyze means choose the right formula, and S means to solve, or actually substitute the numbers in. P is paraphrase. That's if you have to write a sentence explaining your answer. So I want to just quickly do number 5, at least the first. Actually, I'm going to do the second scenario here. It says when the resistor is attached to 4 1.5 volt cells, the current is measured at 0.1 amps. In this whole question, it's trying to ask you, what is an ohmic resistor? An ohmic resistor is a resistor that keeps the same resistance no matter what. And if we just calculated this, you have to calculate resistance in all three of these, but what I'd like you to do is see that you can take the voltage here. It's 4 times 4 times 1.5 volts. Okay, so that's actually going to be 6 volts. Okay, so you have to catch that because there's 4 1.5 volt cells. The current, though, the current would be, in this case, 0.1 amps. So there I've done what's given. It's asking me what is the resistance. So R, if you look at the equation, the original equation is voltage is equal to current times resistance. If you divide both sides by the current cancels on the right side, and then you have a new expression, resistance is equal to voltage divided by current. Some of you guys are already seeing how to do that, but I want you to be conscious of finding the right formula. That's analyzed. We just analyzed the right formula here to solve for resistance. So now you just substitute in your numbers. This would be 6 volts divided by 0.1 amps.